This conference will now be recorded.
So what is our last class? Distributions
Is
with,
about z-score and standard normal distribution.
okay. Now for this particular session, we would like to start a probability concepts. Okay, so the basic statistics and intermediate of statistics were done, and we have to discuss some more information, and situation by situation, topic by topic, I can discuss about those particular topics as well. Okay, but now let's concentrate on probability. So I think if your mathematical background, then it could be easy for you, and if not, don't worry, it can, I would like to start from the scratch, okay, of related to probability as well, so it can be easy for you again. Okay, okay, so let's open your document. Guys, as of now I got a message from the Karthik, Kishore, and Jyoti and Manasa and Deepika only. What about others? Okay, side heading, guys. Today we'll talk about probability. I hope you can see my screen. Yes or no? What exactly the probability? Do you have a knowledge on the probability before that? If yes, please say yes. If no, please say no. So probability is nothing but it's a measure of, so something you are doing some, for example, you are doing some particular experiment. By the time you want to know that some likelihood event actually, okay. So measure of the likelihood event in the experiment. So that we are calling it, say, probability, likelihood of an event. So for example, let me consider a small example. You have a coin. Okay, so let's go for understand what exactly the probability. So for example, you have a coin and the coin you tossed. Okay, so what could be your results? It can be tail or it can be head, right? So when you toss your coin, then you might be getting the two options only, either head, either tail. So I want to find out the likelihood, measure of the likelihood of this event H, and I want to find out the likelihood event for the tail. Okay, so that means probability of H is nothing but it's a likelihood of event H, and I want to find out the probability of the tail is nothing but it's a likelihood of an event tail. So that's we are calling it, say, probability. Okay, so now if you want to calculating the probability, so you need to remember the two things. When we are doing one particular experiment, when we are doing one particular experiment, that experiment you did 10 times, you did 10 times. For each time we are good, so you are doing one particular experiment 10 times, that means for each time we are getting the event 1. So by the time of experiment 1 we are getting some result, right? That you can consider it's a event 1. And for second time of experiment you are getting the event 2, and for example third time again you are getting the event 3, for fourth time again we are getting the event 1. Okay, for example fifth time we are getting the event 2 again. See, and so on. For example, you are doing the one experiment with 10 times, then you might be getting the 10 events. You might be getting the 10 events. The total possibilities, we are calling it a sample. So sample space, usually we are calling it a sample space. What does it mean that sample space? Sample space in the sense, when you did one particular experiments, then that all times of experiments, the results we are collecting in one particular place, that we are calling it same sample space. Okay, that we are representing with capital S. That we are representing with capital S. Did you got my point? Did you got my point or not?
Yes.
Yeah. So here we are getting the results, right? That results we are calling it the events. So these are the results, right? These are the results we are calling it the events, and the total number of events in one particular experiment, that we are calling it say sample space. I hope you understood my point, right? So let me consider probability of event. So I just want to find out the probability of any one of the event. Then the event, you can consider it could be the E. So you can say that it's a probability of E equal to total number of total number of total number of getting events, total number of occurred events, or likelihood events, nothing but likelihood of event, likelihood of an event by total number of events. That means sample space, total number of events. Okay, for example, let me consider a small example for understanding this one. I just toss one particular coin. I just toss one particular coin. Okay, then here I can get the options either tail, either hedge, all possible outcomes. All possible outcomes, we are calling it a sample space. So here you might be getting the chance either tail, either head. So here total number of elements, that means sample space. What it is, this is my sample space, and total number of sample space in the sense all possible outcomes. Here I have the 2, and the total number of h, that means how many times the h is occurred here. It's a one time. Total number of tails, it could be 1. Okay, that means event of h is 1, event of tail is 1. Now I want to find out the probability of the head. So probability of the head equal to number of events occurred head by total number of possible outcomes, that means sample space. Okay, so here the number of h will be the 1, and number of possible outcomes are 2, so that your probability is becomes 0.5. Okay, so here we need to remember one thing actually, the probability of anything, it could be in between 0 to 1. So the probability is not less than the 0, the probability is not more than the 1. So if you are getting that kind of answers, then it's wrong. I hope you understood, right? The probability range, it could be in between 0 to 1 only. Is it clear? Is it clear or not?
Yes, sir.
Yes, sir.
Yes, sir.
Can you please note this all information? I can wait for it. So once done, you can raise your voice, guys. Done, right? You just note this particular value. The probability of any event, it could be in between 0 to 1. Okay. Now, let's say have the one more example. So usually we can see this kind of questions, guys. Okay. So for example, you or roll one particular die. So when you when you roll one particular die, here we have options are getting the either one. Actually, the roll having the 6 phases, right? Okay, so 6 phases, and one phase will be 1, second phase, and it could be the 2 and 3 and 4 and 5 and 6. Okay, so here the sample space, it could be this one. Okay, the sample space could be this one, and here the event of 1, it could be 1, the event of 2, it could be again 1, and the event of 3, it which is also 1. That means the 3 is repeated in this particular sample space in only one time. So that you just noted this all number of events of each event, and number of 6, it could be the 1, and what could be my number of sample space, that means n of s, how many number of possible outcomes we have it when you roll one particular die in one time. So there are 6 possibilities are there, so that the total possible outcomes are 6. Now I want to find out the probability of 1, then the number of events of 1 by the number of possible outcomes, and it could be 1 by 6. Is it clear? And so on. So I mean, probability of 2 also will be getting the same thing. Can you please note this example? Hello? Now, we have some rules are there in a probability. Okay, so there are different kind of rules, and it could be addition rule, multiplication rule, something like this. Let's go for understanding the first one is additional rule. Additional rule. When you're thinking about additional rule, so basically the probabilities are two type of events you might be getting. So when you're doing one particular experiment, you might be getting the two kind of events. One is mutual exclusive events, mutual exclusive events, and second one is non-mutual exclusive event. Non-mutual exclusive event. Okay, tell me what exactly the mutual exclusive event and what is a mutual exclusive event. Tell me, guys. Mutual exclusive event in the sense, okay, so there is a two events. There is a two events, okay. The two events are mutual exclusive when they can't occur in a one same time. Can't occur in the same time, at the same time. So that means when you're doing one particular experiment, you can't get the two results. You can't get the two results in a one time, in the same time. That we are calling it, say, mutual exclusive events. Non-mutual exclusive event in the sense, at the same time, you might be getting the multiple events. Multiple events. That we are calling it, say, okay, non-mutual exclusive event. For example, India-Pakistan match of cricket. Okay, so that means the India and Pakistan can play same time. Same time they will play only one time, right? Same time they will play only one time, right? Okay. For example, same Pakistan and India matches, but it could be one could be the cricket and one could be the for example kabaddi, okay, or else some other game. See here, kabaddi and kho and cricket, these are the three different games. So by the time the event at the same time, there are multiple events will happening in one particular situation. Is it clear that we are calling it a non-mutual exclusive event? Mutual exclusive event in the sense, in the same time it can occur only one possible outcome. That's we are calling it a mutual exclusive event. Clear? Is it clear? Is it clear or not?
Yes, sir.
Yes, sir.
Okay. Yeah. So when it could be the mutual exclusive event, and the probability, for example, A and B are the events, okay, at different times. This event and this sample space and this sample space, okay, and both are non mutual exclusive. A and B are mutual exclusive. That means in the same time you could not get from the A and from B, we could not get the same event. Okay, we could not get the event in the same time. So in a different time zones or different times, these events will happening. So that's the reason the probability of A, okay, you can say that it's R. The probability of R, you can say that's union also. You can say that's a probability of A union B. So when it is both are mutual exclusive, then probability of A plus probability of B. This is the formula you need to remember. Okay. For example, if it is a non-mutual exclusive event, okay, non-mutual exclusive event in the sense there might be a chance the both events will happening in the same time. Okay, so that's the reason probability of A and probability of B. And when you're combining these two things, maybe you are for example 1 plus, so here for example probability of 5 and this is probability of B, but there is a chance both will happening in one time also, right? So I want to remove any one of it, so that's the reason we can use probability of the A intersection of B. Okay, so this is the formula for the non-mutual exclusive additional rule, and this is for mutual exclusive additional rule. Okay, just note these two examples, I mean these two formulas. Okay. See guys, one of my student is writing a small exam, is an interview. I just, he needs some help actually. So can I leave now?
Sir, we do have Python class.
No, we have direct machine learning, deep
ML.
learning. Yeah, deep learning. I would like to start deep learning. That is a new model. If anyone want to listen that particular class at 8 p.m. as for IST, you can come for it. That is a new model. So that's not related to Python. That's not related to any one of it. You can come for that
Okay,
particular
sir.
if you're
Okay,
interested.
sir. Okay, sir. Sir, I do have some doubts about Spanish. That
That's
point
perfect.
prediction.
One of student is having just 10
Okay,
minutes of.
okay. You can tell me at 8 in
Yeah.
ML.
Okay. Yeah, bye.